In the deepest regions of space, there are objects that look so unusual that even among countless galaxies, there are almost unbelievable exceptions. One such object is Hoag's object. At first glance, it seems as if not an ordinary galaxy appears before the eye, but something created according to completely different laws. The bright golden core is surrounded by an almost perfect ring of dazzling blue stars, and between them lies a vast region of darkness. This emptiness looks so regular and so clearly separates the center from the outer structure that the object produces a sense of cosmic mystery, the origin of which has not yet been fully revealed.
Among the galaxies of the universe, there are spiral systems, elliptical giants, dwarf structures, and chaotic clusters of stars. But Hoag's object doesn't seem to want to belong to any of the usual categories. Its shape is so unusual that even after decades of research, it remains the subject of numerous hypotheses. This is not just a beautiful galaxy. This is an object that questions some ideas about how galactic structures can form in the first place. Light from this system travels hundreds of millions of years through space before reaching Earth. This means that the observed picture belongs to the distant past. When this light left the galaxy, the processes that determined the modern appearance of the universe were still going on in vast areas of space. And yet, even among ancient cosmic structures, Hoag's object looks almost impossible. The central part of the object is a relatively compact spherical cluster of old stars. Their age significantly exceeds the age of the stars in the outer ring. These stars shine a soft yellow light and belong to earlier generations of galactic evolution. However, the most surprising thing begins next. Around the core is a huge ring of young, hot blue stars. They are much younger than the central region and continue to actively form even now. Between the core and the ring is a gigantic intermediate region where the density of stars is unusually low. It is this dark zone that makes the appearance of the object so mysterious. In ordinary spiral galaxies, there is a gradual transition between the central regions and the outer arms. Here, too, there is an almost perfect separation of structures, as if an invisible border runs between the two components. The earliest hypothesis of the origin of the object is associated with a catastrophic collision of galaxies in the distant past. According to this idea, when another system passes through one galaxy, powerful gravitational perturbations propagate outward like a density wave.
Such a wave can compress interstellar gas and trigger a violent birth of new stars as it moves. The result is a bright ring of star formation. Similar processes are indeed observed in other ring galaxies. However, the problem is that most known ring systems retain numerous traces of collisions. Usually, distorted structures, elongated tails of matter, shattered regions of the disk, or the remnants of an intruder galaxy remain. In the case of Hoag's object, such signs are practically absent. This circumstance gave rise to new questions. If the collision did occur, why did the traces of the crash disappear so completely? If there was no collision, how did an almost perfect ring come about?
Another hypothesis suggests the existence of an ancient spiral galaxy, which over time went through an unusual stage of internal evolution. According to this model, in the past, the system may have had a bar, an elongated structure of stars and gas running through the center. Such bars are capable of redistributing matter within the galaxy and creating ring regions of active star formation. But here too, there is a difficulty. Modern observations do not reveal obvious traces of such a structure.
If the jumper existed, it should have disappeared completely, leaving behind only the effects of its impact. Theoretically, this is possible, but the details of such a scenario remain unclear.
Of particular interest is the gas environment of the object. It is gas that plays a key role in the formation of new stars. Hoag's object's outer ring contains huge reserves of hydrogen. These clouds gradually shrink under the influence of gravity, forming new generations of stars. The blue color of the ring is associated precisely with the presence of young, massive luminaries, the surface temperature of which reaches tens of thousands of degrees. Each such star lives for a relatively short time by cosmic standards. It quickly uses up its reserves of thermonuclear fuel and ends its existence with a powerful supernova explosion. These explosions saturate the surrounding space with heavy elements and create the conditions for the birth of the next generations of stars. In this way, the ring remains a dynamic environment of continuous change.
Interestingly, the central region of the galaxy develops in a completely different way. Old stars dominate here. Active star formation is practically absent. It turns out a kind of division of times within one system. The core holds the history of the distant past, whereas the ring represents a relatively young phase of galactic life. As the accuracy of observations improved, even more surprising details began to appear. Within the central gap, individual stellar streams and weak structures of matter are sometimes found. They are too sparse to completely fill the space between the core and the ring, but their existence suggests that the region is not completely empty.
One of the most intriguing features of the object is its amazing symmetry. In the universe, gravity constantly creates asymmetries. Galaxies collide, distort, engulf their neighbors, and are exposed to the environment. Against this background, Hoag's object looks almost perfectly balanced. Maintaining such a structure over huge periods of time becomes a mystery in itself. Even stranger is the fact that a very distant background galaxy can be seen inside the ring. It is located almost in the same line of sight as Hoag's object. The result is a rare cosmic composition. The ring of one galaxy frames the light of another galaxy located much further in the depths of the universe. This random coincidence looks so unusual that it adds even more mystery to the object.
Physical processes within the system continue to be studied today. Computer models try to reproduce the observed structure, but each new model faces difficulties. Some scenarios explain the formation of the ring well, but are not able to reproduce perfect symmetry. Others create symmetry, but require conditions that are extremely rarely realized in nature. Therefore, Hoag's object remains a kind of test for modern ideas about galactic evolution. Any theory of galaxy formation must explain the existence of such objects. As long as this explanation remains incomplete, the mystery continues to exist.
The future of this system is also of interest. The young blue stars of the ring will gradually complete their life cycle. Part of the gas will be spent on the formation of new generations of luminaries. The rate of star formation will decrease over time. The blue ring will become less bright and gradually change its color. In billions of years, the galaxy may look very different. The bright ring will become dimmer. The differences between the core and the outer region will decrease, and the structure itself may begin to slowly transform under the influence of internal gravitational processes. Even then, however, some traces of its unusual origins are likely to remain.
But the main question remains unanswered. Why did this particular galaxy take on such a unique shape? Was it the result of an extremely rare collision? Has it experienced an unusual internal evolution?
Or is there an unknown mechanism of galaxy formation that has not yet been reflected in current models? Each new image and each new dimension only emphasizes the scale of this mystery. In a space containing hundreds of billions of galaxies, Hoag's object remains one of the most unusual objects known.
Its perfect ring continues to glow in the cosmic darkness, preserving the history of processes that took place hundreds of millions of years ago and have not yet revealed all their secrets. And the deeper the understanding of the universe becomes, the clearer the amazing fact becomes clear. Some of the most beautiful objects in the cosmos turn out to be the most mysterious at the same time. But the mystery of Hoag's object becomes even deeper when attention shifts from its appearance to the dynamics of the movement of matter within the system. On a huge scale, the galaxy appears almost motionless, as if frozen in time. However, in reality, each part of it is in continuous motion. Billions of stars orbit around a common center of mass. Gas clouds collide, condense, and disintegrate. Magnetic fields permeate interstellar space. Energy flows are continuously redistributed between different areas of the system. The ring itself turns out to be especially interesting. It is not a solid structure. It is a gigantic region of space within which stars move along their own trajectories. Over time, individual luminaries leave the areas where they were born, and new ones arise from gas clouds.
Despite this constant stirring, the overall shape of the ring is preserved. It is this fact that makes us consider the ring not as a random distribution of stars, but as a consequence of a stable physical mechanism. Some models suggest the existence of special gravitational resonances. Under such conditions, matter can accumulate in certain regions of the galaxy for a very long time. Such resonances can create peculiar zones of gas concentration, where the probability of the birth of new stars increases significantly. If such a mechanism is indeed at work inside Hoag's object, then the ring could represent a gigantic region of steady star formation that has existed for hundreds of millions of years.
However, even this idea does not explain the origin of the original structure. To form such an unusual system, a special combination of conditions was necessary. It is likely that the galaxy experienced an event in the past that completely changed its further evolution. Perhaps it happened so long ago that most of the traces have long since disappeared. The ancient origin of the current form is also supported by the difference in the ages of stellar populations. The central core contains mostly old stars that formed billions of years ago. Their light tells about the early stages of the system's development. The outer ring is much younger. It seems to belong to another epoch of the galaxy's existence. There is a feeling that two different stories coexist within the same object at the same time. The role of dark matter remains no less mysterious. Any large galaxy exists inside a massive, invisible halo whose mass is many times greater than the mass of all stars and gas. Dark matter determines the movement of matter, affects the stability of the structure, and controls the evolution of the system over billions of years. Perhaps it was the peculiarities of the distribution of dark matter that played a key role in the formation of Hoag's object.
If an invisible halo has an unusual configuration, it can create conditions that rarely occur in other galaxies. In this case, the object becomes not just a rare galaxy, but a kind of pointer to processes hidden from direct observation. Then, the ring of stars turns out to be only a visible manifestation of a much more complex invisible structure.
As we studied such objects, another interesting question arose. Is it possible that Hoag's object is not a unique exception at all? There may be many more such systems in the universe, but most of them are too distant and too faint to be studied in detail. If this is the case, then modern galaxy catalogs may contain only a small fraction of such structures. New generations of telescopes are gradually expanding the area of the observable universe. They make it possible to detect increasingly ancient galaxies and study their structure with unprecedented precision. Among these objects, systems that have unusual ring features begin to appear. Some of them resemble Hoag's object only remotely, others show some similarities. Each such find adds new fragments to the complex picture of galactic evolution.
But the more data becomes known, the more difficult it is to give a definitive answer. The universe constantly demonstrates the ability to create structures that do not fit into the usual schemes. Hoag's object is one of the most prominent examples of this phenomenon. It exists as a reminder that even the fundamental processes of galaxy formation are far from fully understood. Particular attention is drawn to the void between the core and the ring. In the pictures, it looks almost absolute. However, behind the outer darkness lies complex physics. In this region, there is rarefied gas, individual stars, and invisible dark matter. Nevertheless, the density of the substance remains unusually low compared to neighboring regions.
The question arises, why does the substance not fill this gap? Gravity tends to redistribute matter and smooth out sharp boundaries. But in Hoag's object, the boundary between the central area and the ring remains remarkably clear. This indicates the existence of processes that maintain the structure over enormous periods of time. It is possible that a powerful density wave passed through the galaxy in the past, pushing a significant amount of gas out. Perhaps certain orbital resonances prevent matter from returning back to the center. It is possible that there was a combination of several mechanisms at the same time. So far, no model has received full confirmation.
The picture becomes even more impressive if you look at the object on the scale of cosmic time. Over billions of years, galaxies typically experience many interactions with their neighbors. They collide, absorb dwarf systems, and change shape under the influence of the environment. But Hoag's object looks like it has managed to avoid most of these events. This could mean that the galaxy spent a significant part of its history in a relatively isolated region of space. This cosmic isolation allowed the unusual structure to persist much longer than is possible in denser regions of the universe. If there were large galaxies nearby, their gravitational influence could have destroyed the ring's perfect symmetry long ago.
Over time, the mystery becomes no less philosophical than astronomical. Each such object shows how diverse the universe can be. The laws of physics are the same for the entire cosmos, but the results of their action can take forms that seem almost unbelievable. Some galaxies turn into giant spirals, others become elliptical giants, and some create structures like Hoag's object, so rare that they continue to raise questions even decades after discovery. And perhaps the biggest mystery lies not in the ring itself, nor in the origin of the void between the structures. The biggest mystery is that somewhere among countless trillions of stars and billions of galaxies, nature was able to create an object that still has no universally accepted explanation. The light of this galaxy continues to travel across the cosmic abyss, carrying information about the events of the distant past. And along with this information, a mystery moves through space and time, which remains unsolved today.
If you try to trace the history of Hoag's object even further back in time, the picture becomes increasingly uncertain.
The current view of the galaxy is just one moment of its vast biography, stretched over billions of years. Once upon a time, this system looked different. The young stars of the current ring did not yet exist. The gas was in other regions of space. The orbits of billions of stars had a different configuration. And somewhere in that ancient era, an event occurred, the consequences of which are still preserved. One of the most difficult tasks remains the reconstruction of this distant past. The cosmos does not keep detailed records of its history. It leaves only traces. The distribution of stars, the movement of gas, the chemical composition of various regions of the galaxy, all this resembles fragments of a huge puzzle, most of which has long been lost. Hoag's object is especially difficult precisely because many of the key traces of its formation have been erased by time.
The age of the various stellar populations shows that the ring did not arise at the same time as the central part of the galaxy. There is a significant time gap between them. This means that the system has gone through at least two major stages of evolution. First, the central core was formed. Then, after a long period of time, the process began that gave rise to the outer ring of young stars. Such a sequence of events is unusual in itself. Most galaxies evolve more continuously. In them, new generations of stars gradually appear in different regions of the disk. In Hoag's object, the activities seem to be concentrated in a specific area of space. The reason for this behavior is still a subject of discussion.
Of particular interest is the chemical composition of the ring. Each element heavier than hydrogen and helium appears inside stars and spreads after they die. Therefore, the chemical composition makes it possible to restore the history of star formation. The analysis shows that the matter of the ring has already gone through several cycles of the birth and death of stars. This means that the structure has been around for much longer than it might seem at first glance. The young blue stars that dominate the ring today are only the latest generation in a long sequence of cosmic events. Before them, there were other generations of luminaries who had already completed their existence. Their explosions enriched the interstellar gas with heavy elements and prepared the material for the formation of new stars.
Each supernova explosion inside the ring becomes a local catastrophe of colossal proportions. In a matter of seconds, energy comparable to the radiation of an entire galaxy is released. Shock waves propagate through the interstellar medium, compressing neighboring clouds of gas. Sometimes this triggers the birth of new stars, and sometimes, on the contrary, destroys the structures that are forming. As a result, the ring is a complex, self-regulating system where destruction and creation are constantly replacing each other. The processes in the central core remain no less mysterious. Despite its relatively calm appearance, a huge amount of mass is concentrated there. Billions of old stars create a powerful gravitational field. At the very center is probably a supermassive black hole, as is the case with most large galaxies. However, its activity today looks very moderate.
This circumstance also raises questions. If the central black hole has been an active phase in the past, its radiation could have seriously affected the surrounding gas. Some models suggest that powerful energy releases may have been involved in the redistribution of matter within the galaxy. It is possible that some of the gas was forced out of the central regions, which indirectly contributed to the formation of the current structure. Similar processes are observed in other galaxies.
When a supermassive black hole begins to actively absorb matter, it is able to eject colossal streams of energy. These streams heat the surrounding gas, change the rate of star formation, and affect the further evolution of the entire system. If something similar happened at Hoag's object billions of years ago, modern observations can only see the distant consequences of those events. But even the most complex models are not yet able to reproduce all the features of the object at the same time. This is its uniqueness. Usually, astronomical riddles gradually lose their mystery as data accumulates. In the case of Hoag's object, the opposite happens. Each new observation helps to better understand individual details, but the overall picture remains surprisingly elusive. Sometimes another curious possibility catches your attention. What if the current appearance of the object is an extremely short-term phase of its existence? On the scale of billions of years, even a few 100 million years is a relatively short period. It is possible that the galaxy is in a rare transitional state between two more ordinary forms. If this is the case, then humanity is observing the system at an exceptionally fortunate moment in its history.
This idea makes the object even more interesting. Of the billions of galaxies, this one could have been seen in an era when its structure reached its maximum expressiveness. After a few billion years, the ring may become less visible. The boundaries between the components will blur, and the galaxy itself will begin to resemble more familiar systems. However, there are models according to which the ring structure can be preserved for an incredibly long time. If the mechanism for maintaining it is truly stable, the galaxy can remain recognizable for many billions of years. In this case, Hoag's object becomes an example of how diverse the stable states of galaxies can be. As the observable part of the universe expands, another important question arises. Did such objects exist in the early universe? If ring galaxies could have formed shortly after the first large star systems appeared, it could change the way we think about early cosmic evolution. Perhaps such structures were more common in the past, and only a few have survived to this day. The search for the answer continues among increasingly distant galaxies. Each new object is compared to Hoag's object. Each unusual structure becomes a potential clue to its origin. But so far, this key has not been found.
And that's why Hoag's object remains one of the most unusual galaxies in the known universe. It seems to exist on the border between the explainable and the unknown. Its perfect ring surrounding the ancient core continues to retain traces of events that occurred long before the appearance of modern stellar generations. And the deeper the understanding of the cosmos becomes, the more clearly one feature of this galaxy is revealed. It does not just decorate the universe with its unusual shape. She reminds us that even among objects that have been observed for a long time, there may be mysteries that can change ideas about how the universe itself forms and develops.
As the study of Hoag's object becomes more detailed, attention gradually shifts from its external appearance to the surrounding outer space. No galaxy exists in complete isolation. Even the most distant systems are part of a vast network of gravitational bonds that permeates the universe on all scales. Threads of dark matter connect galaxies to each other, forming a giant cosmic web. Through these structures, matter moves slowly over billions of years, fueling the growth of galaxies and changing their fate. The question arises,
What role did this invisible network play in the history of Hoag's object? Perhaps the ring is the result of an unusual flow of gas from the surrounding space. If a galaxy received matter along a certain trajectory for a long time, this could lead to the formation of a stable external structure. Such a scenario looks less dramatic than a galaxy collision, but it can explain some features of the system.
Gas falling into the galaxy from intergalactic space rarely moves chaotically. Gravity guides it along the threads of the cosmic web. Over millions of years, these streams can carry huge masses of matter. Once in the galaxy, they change the distribution of mass, affect the rotation of the system, and trigger new waves of star formation. Perhaps the current ring is the result of processes that have been going on for an incredibly long time and remain almost imperceptible against the backdrop of brighter cosmic events. Especially interesting is the rotation speed of various regions of the galaxy. Under normal conditions, the inner parts of a galaxy and its outer regions move differently. This difference gradually leads to a redistribution of matter. However, Hoag's object retains its shape despite billions of years of rotation. This means that there is a complex balance of power inside it. Each star in the ring moves in its own orbit. Some are closer to the center, others are farther away. Their speeds are different. For a long time, such a system would have to lose its clear structure, but this did not happen. Consequently, the ring is supported by a mechanism that compensates for the destructive influence of internal dynamics. One of the most intriguing features remains the almost circular shape of the ring. In the universe, perfect circles are extremely rare. Even small gravitational perturbations can create asymmetries. Nearby galaxies, uneven mass distribution, internal instabilities, all this usually leads to the appearance of deformations. Nevertheless, Hoag's object ring remains surprisingly correct.
Such symmetry makes one wonder how rare the set of conditions that gave rise to this object can be. It is possible that there are only a small number of systems in the entire observable universe that have gone through a similar formation scenario. If so, Hoag's object becomes not just an unusual galaxy, but a real cosmic rarity. The more data you can collect, the stronger another feature appears. Despite its unusual shape, the galaxy itself remains stable. It does not look like an object on the verge of destruction. On the contrary, all signs indicate that the system has existed in this form for a very long time. This means that the mysterious structure is not a random anomaly. It is a stable state that nature has somehow been able to create and preserve.
Sometimes, individual bright areas inside the ring attract attention. These are regions of active star formation, where the density of gas is higher than average. It is there that the most massive stars of the system are born. Their powerful ultraviolet radiation causes the surrounding gas to glow, creating bright bluish areas that are visible even at great distances. Each such region is a kind of laboratory of extreme astrophysics. Inside dense gas clouds, new star clusters appear. Young stars quickly heat the environment, form shock waves, and create powerful stellar winds. These processes affect the further distribution of matter in the ring and determine its future evolution.
But if you look even further, it's clear that Hoag's object touches on much more fundamental issues. It makes you think about how complete modern ideas about galaxy formation are. Most existing models are based on the statistics of millions of objects. They successfully explain general patterns, But systems like Hoag's object remind us that nature is capable of creating exceptions. It is the exceptions that often turn out to be the most important. They show the limits of existing theories. They point to processes that have not yet been sufficiently studied. Sometimes one unusual galaxy is able to tell more about the universe than thousands of ordinary objects.
Especially curious is that Hoag's object exists in an era when galactic evolution has already slowed down significantly compared to the early universe. In the distant past, collisions occurred more frequently, star formation was more intense, and the environment was much more dynamic. Many modern galaxies are the result of a long chain of such events. However, the story of Hoag's object looks different. It seems to have preserved the trace of a rare process that either occurred extremely rarely or went unnoticed among many other mechanisms of formation.
With each billion years, its appearance will slowly change. The young blue stars of the ring will gradually disappear. Some will turn into neutron stars. Others will end their existence with supernova explosions. Gas reserves will be reduced. The rate of birth of new stars will become slower. Gradually, the bright ring will begin to lose its dazzling blue color. The light of the system will become calmer and reddish. The galaxy will enter a new phase of existence. However, even then, its unusual structure can persist for a very long time.
But there is another scenario. In the future, billions of years from now, another galaxy may pass nearby. Even a distant approach can upset the delicate gravitational balance. The ring will begin to warp. The orbits of the stars will change. A structure that has been preserved for an incredibly long time will gradually dissolve into a more complex configuration. If this happens, one of the most unusual shapes known in the universe will disappear. But until that happens, Hoag's object continues to exist as a cosmic mystery, frozen in the abyss of space. Its light continues to cross hundreds of millions of light years. Its ring continues to give birth to new stars. Its origin remains a matter of debate, and its history still holds answers to questions that have yet to be formulated. And perhaps that's the most surprising feature of Hoag's object. It reminds us that even among the billions of known galaxies, the cosmos is able to preserve secrets whose origins remain hidden beyond the current understanding. It seems as if the very structure of this galaxy is a message from the distant past of the universe, a message that has not yet been fully deciphered.
The longer Hoag's object is considered in the context of the general history of the universe, the more unusual its position among other galaxies becomes. Many cosmic structures show traces of their origin quite clearly. Spiral arms indicate the processes of disk formation. Giant elliptical galaxies often bear traces of numerous ancient mergers. Irregular galaxies show the effects of gravitational perturbations and collisions. Hoag's object seems to be hiding its own past. It demonstrates the result, but almost does not show the path that led to it. This feature turns the object into a kind of archive of ancient cosmic events. Inside its structure, traces of processes that took place billions of years ago must be preserved.
They are hidden in the distribution of stars, in the velocities of gas movement, in the chemical composition of individual regions, and in the form of a gravitational field. Each of these details may contain information about the origin of the ring, but so far, not all the fragments add up to a single picture. Particular attention is drawn to star clusters scattered around the outer ring. Many of them are relatively young by cosmic standards.
They contain thousands or even millions of stars born almost simultaneously from a single giant cloud of gas. Such clusters become a kind of timestamps. Their age allows us to reconstruct the history of star formation and determine exactly how the ring evolved over millions of years.
Some areas show signs of more active star formation than neighboring areas. This suggests that the ring is not completely homogeneous. Local changes are constantly taking place within it. Gas clouds move, collide, and contract under the influence of gravity. In some regions, new generations of stars appear. In others, activity gradually fades. Despite the external symmetry, there is a complex and dynamic environment inside the ring. It is also interesting that young massive stars in the ring are powerful sources of radiation. They release huge streams of energy into the surrounding space. Their stellar winds move at speeds of hundreds and thousands of kilometers per second. These streams affect neighboring gas clouds, change their structure, and are able to trigger new cycles of star formation.
Thus, the ring is not a static structure, but a huge region of continuous activity. While some stars are coming to an end, others are just emerging. While some gas clouds dissipate, others begin to contract. This is an endless cycle of transformations stretched over billions of years. However, behind this activity lies an even more fundamental mystery. Why are the processes of star birth concentrated in the ring and not distributed throughout the galaxy? Why is there such a sharp separation between the old central core and the young outer structure? The answer to this question may be related not only to the history of Hoag's object, but also to the general laws of galaxy formation.
Some models suggest that the galaxy may have absorbed large amounts of external gas in the distant past. This gas gradually settled at a certain distance from the center and began to form a ring structure. If this scenario is correct, then Hoag's object could be an example of an extremely rare form of accretion of matter from the intergalactic medium. This possibility is especially interesting because intergalactic space is not empty at all. There is rarefied gas between galaxies that moves slowly along the threads of the cosmic web. Over billions of years, these streams are capable of carrying colossal masses of matter. Usually, such processes are difficult to notice directly, but their effects can persist in the structure of galaxies. If the ring is indeed associated with the ancient influx of matter from the surrounding space, then Hoag's object becomes important evidence of processes that occur on a scale throughout the universe. Then its unusual shape turns out not to be an accident, but a reflection of the complex mechanisms of galaxy growth. As telescopes improve, it becomes possible to study increasingly faint details around an object. And this is where new mysteries arise. Some observations indicate the existence of extremely faint structures outside the main ring. They are so faint that they are difficult to study in detail. But if their existence is conclusively confirmed, it could significantly change the way we think about the galaxy's past.
Such structures can turn out to be the remnants of ancient interactions. Perhaps billions of years ago, another galaxy passed nearby. Perhaps there was an absorption of the dwarf system. Perhaps the current ring is a distant consequence of events that ended long ago. Even the weakest residual structures can contain important clues. Even more intriguing is the idea of how many such objects can lurk in the depths of space. Today, billions of galaxies are known, but only a small part has been studied in detail. Many systems are so far away that their structure looks like just a small spot of light. Among them may be thousands of objects that resemble Hoag's object, but are not yet available for detailed exploration.
If such galaxies turn out to be more common than is currently believed,
it will require a revision of some ideas about galactic evolution. Then, Hoag's object will cease to be a unique exception and will become the first well-studied representative of a much larger class of objects. But so far, the available data suggests otherwise. Such systems remain extremely rare. It is this rarity that makes them especially valuable. Each such galaxy becomes a kind of experiment of nature, allowing us to study processes that are almost never observed in other conditions.
Over time, the story of Hoag's object will inevitably continue. Even if its shape persists for billions of years, changes will still occur. Gravity slowly redistributes orbital energy. Young stars age. Gas reserves are decreasing. Dark matter continues to direct the movement of matter. Imperceptible processes gradually change the appearance of the system. But today, hundreds of millions of years after its light traveled through space, Hoag's object remains one of the most mysterious galaxies known to mankind. Her ring shines in the darkness of space like a trace of an ancient event that has not yet revealed its nature. And the more closely this system is studied, the clearer the sense becomes that unraveling its origin could lead to discoveries that go far beyond a single unusual galaxy. Perhaps it is in its structure that clues to understanding the processes that formed galaxies throughout the history of the universe are hidden. This means that its mystery remains part of a much larger mystery, the history of the cosmos itself.
This story becomes even more mysterious if we consider Hoag's object not as a separate galaxy, but as the result of a long chain of events that stretched over a significant part of the age of the universe. Each major structure of the cosmos is formed gradually. Billions of tons of gas are collected by gravity. The first stars appear. Their radiation changes the environment. The next generations of stars are born in different conditions. For billions of years, the galaxy has been constantly changing. However, in the case of Hoag's object, the outcome of this evolution turned out to be so unusual that it still looks almost unbelievable.
Especially surprising is the fact that the outer ring contains a huge number of young stars, but does not show signs of the chaos that usually accompanies active star formation. In many galaxies, such processes lead to complex spiral structures, bright bars, or asymmetrical regions of increased density. Here, the activity seems to be organized according to very special rules. Stars are born inside the ring, but the ring structure itself remains remarkably stable. This makes us think about the nature of the orbits inside the galaxy. It is possible that a significant part of the matter moves along the trajectories that naturally support the ring. In this case, the geometry of motion itself becomes the key to understanding the object. It is possible that billions of stars form a complex system of orbital resonances that exist over vast periods of time. Similar resonances are found in other space systems. They are able to organize the movement of matter in such a way that certain areas become denser, while others remain relatively empty. If such a mechanism is at work in Hoag's object, then its famous gap between the nucleus and the ring may not be the result of a catastrophic event, but the natural result of the long-term gravitational organization of matter. However, this hypothesis raises a new question. Why are similar structures so rare among other galaxies? If the mechanism is relatively simple, there should be many more such objects. If it requires an exceptionally rare combination of conditions, then Hoag's object becomes evidence of one of the most unusual scenarios of galactic evolution.
An equally important role can be played by the distribution of angular momentum. When matter gathers into a galaxy, the direction and speed of its rotation determine the future structure of the system. The slightest differences in the early stages can lead to completely different results in billions of years. Perhaps Hoag's object story began with a highly unusual configuration of a rotating cloud of gas back in the era of the formation of the first components of the galaxy. If this is the case, then the clue to its origin may lie not in relatively recent events, but in the earliest stages of the system's existence. Then, the ring turns out not to be the result of a separate catastrophe, but the final result of processes that began billions of years ago and gradually formed the current appearance of the object.
Another mystery remains the distribution of mass within the galaxy. Visible stars make up only a fraction of the total mass. Invisible dark matter plays a much larger role. It forms the gravitational framework that keeps the galaxy from collapsing. If the structure of the dark halo around Hoag's object is different from typical galaxies, this could explain many of its features. Some models allow for an unusually symmetrical distribution of dark matter around the object. Such a distribution could help maintain the correct shape of the ring for billions of years. So far, it is extremely difficult to test such ideas since dark matter itself remains one of the main mysteries of modern cosmology.
This is where Hoag's object begins to intersect with fundamental questions about the structure of the universe. It is no longer just about the origin of a single galaxy. Questions arise about the nature of dark matter, about the mechanisms of formation of large structures, and about how well modern science understands the processes taking place on cosmic scales. As technology advances, it becomes possible to study the galaxy in different ranges of the electromagnetic spectrum. Visible light shows the distribution of stars. Infrared radiation allows you to explore colder areas. Radio observations reveal the structure of gas clouds. Each range adds new details to the overall picture.
And almost every new dataset brings new questions. Sometimes it turns out that the gas is not distributed quite as expected. Sometimes the peculiarities of the rotation of individual areas are revealed. Sometimes there are hints of ancient processes that previously remained unnoticed. Instead of a definitive answer, an even more complex mystery arises. This is what happens with many great mysteries of the cosmos. The more information that can be obtained, the clearer it becomes how complex reality is. Hoag's object is one of the best examples of this phenomenon. Its extraordinary beauty attracts attention at first sight, but behind this beauty lies an extremely complex physical system, the history of which has not yet been fully restored. Yet the most intriguing possibility is that current ideas about the object's origins may be only part of a deeper story. It is possible that future observations will reveal facts that will completely change the view of this galaxy. It is possible that new objects with a similar structure will be found. Perhaps there will be models explaining its origin in a completely unexpected way. Or perhaps Hoag's object will turn out to be a manifestation of processes that are not even included in existing cosmological theories yet. Therefore, her story remains open. The light of this galaxy continues to cross the cosmic abyss, carrying information about events that occurred hundreds of millions of years ago. The outer ring continues to shine with young stars. The ancient core preserves the memory of the distant past, and between them still lies a mysterious region of space, a silent reminder that the universe is still far from fully understood, and continues to keep secrets even in objects that seem to be well understood.